All right, hello everybody. Today we're going to observe a decomposition reaction with potassium chlorate, and then we're going to see a little secondary reaction as well that is created from the products of this reaction. So we are going to observe the decomposition of potassium chlorate. That's the white substance here in this test tube. When it is heated, it will become molten, and then it will actually decompose. Now, when it decomposes into potassium chloride and also oxygen gas. So much oxygen gas is produced that we can actually cause a combustion reaction to happen with this tiny little gummy bear. This gummy bear, as you remember, has sugars in it, which is a hydrocarbon, also some oxygen in that compound as well. When we put this into the test tube, there is a heat present, obviously, and oxygen. Those are the three things we talked about that are required for a combustion reaction: heat, a hydrocarbon fuel source, and oxygen. So let's take a look and see what happens in this secondary reaction with our gummy bear. Oh my gosh. Poor gummy bear is no longer, as he combusts in this very oxygen-rich environment from that potassium chlorate decomposition. Just an amazing reaction. I've always wanted to do this, but it looks so terrifying and dangerous that I've never tried. All right, so how much oxygen gas did we produce? That's what I'm wondering. So today I want to show you how we could figure that out. All right, so here's a question on our introduction to stoichiometry sheet. It says, how many grams of potassium chloride are produced if 25 grams of potassium chlorate decomposes? So I would like to know, instead of grams of potassium chloride, let's find grams of oxygen, because that's actually more interesting to me based on the secondary reaction that happened. So we are always in stoichiometry going to start with what's given in our problem. In this case, what's given is 25 grams of potassium chlorate. So 25.0 grams of KClO3. Now, I am noticing now that my equation is not balanced, so let me go ahead and balance that really quickly. So 2 to 2 to 3. All right, so I want to be able to relate, as I said, this potassium chlorate to the oxygen. So these are the two things I'm interested in for this problem. So I want to know how much oxygen gas is produced from this 25 grams of potassium chlorate decomposing. In order to do that, in order to compare these two things, or to relate them rather, using this ratio in the balanced equation, 2 to 2 to 3, in order to use those, I have to be in moles, because this is a molar relationship in the balanced equation. So I need to know how many moles of potassium chloride decomposed, and then I could relate that moles of potassium chlorate to moles of oxygen. From there, I could then get grams of oxygen. So first, I'm going to convert this grams of potassium chlorate into moles. So I know that for every 1 mole of potassium chlorate, it weighs whatever its molar mass is. So potassium is 39.10 grams, chlorine is 35.45 grams, and then there's 3 oxygens that are 16 grams each. So that's a total of 122.55 grams. Okay. All right, now I'm in moles of KClO3. So now I want to relate that KClO3 and that O2 using the mole ratio like we did last week. So that is a 2 to 3 ratio. If I want to get rid of moles of KClO3 and go to moles of oxygen, my moles of KClO3 must go in the denominator. And my moles of oxygen must go in the numerator. Now, when I look, this is not going to be a 1-to-1. So over here for our molar mass is always the mass of 1 mole. But this is not molar mass over here. This is mole ratio. And remember that mole ratio comes from the coefficients in the balanced equation. So for every 2 moles of KClO3, I produce 3 moles of oxygen. And I'm just going to like highlight that in a different color so you can see where this is coming from. So 2 moles of this, 3 moles of oxygen, that's where this term came from. All right, and then the problem doesn't ask for moles of oxygen, it does ask for grams. And we just canceled out this unit. This unit also canceled earlier. Sorry, I didn't say that. So if we want to get rid of moles of oxygen and go to grams of oxygen, I know that every 1 mole of oxygen is equal to 32 grams of oxygen. That's its molar mass. Again, I'm putting this moles of oxygen on the bottom because I want it to cancel with that moles of oxygen on the top in the numerator. So then I'm ready to solve. Remember, when we solve these, we multiply everything in the numerator and divide by every number in the denominator. So it's 25 is over 1, because that's just a whole number. So 25 times 1 times 3 times 32, divided by 122.55, divided by 2, divided by 1, gives me 9.79 grams of O2. So when that sweet little gummy bear combusted, it was combusting with that 9.79 grams of oxygen that was produced from that reaction.